Now we'll try to use bootstrapping to get a confidence interval for the true slope of the regression line. To get a confidence interval for the true slope, you first bootstrap the scatter plot. That means that you start with your table and you use the .sample method in order to bootstrap the scatter plot. It means select the number of rows in the table, um, rows from the table, but we select them with replacement. So sometimes the rows will appear multiple times and sometimes they won't appear at all. Then from this new data, from this new table, you find the slope of the regression line. And then you repeat this many, many times, each time collecting the slope and storing that. And then you draw the empirical histogram of all the generated slopes, and you get the middle 95% interval. That's an approximate 95% confidence interval for the slope of the true line. Of course, if you wanted a 90% confidence interval, you'd get the middle 90% of the empirical histogram of generated slopes. Let's look at this in an example in the demonstration. Let's look at the baby weight example, and we'll see how baby weight in ounces here in the table varies based on gestational time, number of days spent in the womb. And to start, we'll take this table and just select the 0th row and the first row, that is kind of subsetting our table and making it a little bit smaller. Then we'll calculate this number, weight per day, which is calculated here using the slope function that we defined up above. We have to give the table that we're working with, the predictor variable, in this case gestational days, and the response variable, the variable that we're trying to predict, the birth weight. And then we'll print the slope of the regression line. And here I'll also try to draw the scatter plot with the regression line. And here you see it, a nice scatter plot with the regression line, and the slope here is 0.466557. And that's in ounces per day, right? That means that we estimate that a baby gains about 0.46 ounces per day spent in the womb. Let's check to see if our assumptions about the model are right. Does the error depend on the predictor variable? Let's see. Here's a residual plot. We're using the baby table, and here we've got the predictor, and here we've got the response variable, and we use the residual plot command that we defined up above in order to plot the residual plot and also the residual equals 0 line. And here, this looks pretty good. It's possible that maybe there's some outliers here or there, but it looks okay. Maybe I'm a little worried about the gestational days here. When gestational days is higher, it looks like the residuals maybe are a little are consistently low as opposed to a spread of low and high, and that might make me a little bit worried. But generally, this plot looks pretty good. I'm particularly paying attention to the spread of the residuals, and they seem to spread pretty much evenly across the data, across the predictor variable gestational days. One thing you might worry about is how much could this estimate have changed if we had a different sample? Let's find a 95% confidence interval for the weight per day ratio. And to do that, we'll use 1,000 repetitions, and we'll make an empty array to store the slopes. And for each time through this loop here, for each of the 1,000 times through this loop, we'll calculate a new table by using the sample command. That's our bootstrapped sample. Then we'll calculate a new slope using the slope command and this new table. Be careful to use the new table. So we use new data. And then we'll append the slope to the new slope to the slopes array. And then here's the table of histograms plotted. Very nice. And from this, you could calculate, from this slopes array, you can calculate the 2.5 percentile and the 97.5 percentile to calculate the middle 95% of these values. And we find that the 95% confidence interval for the slope is 0.384 to 0.559. And that means that 95% of the time, this interval would contain the true slope. We don't actually get to ever see the true slope, but we think that it might be somewhere between 0.384 and 0.559 ounces per day.